This is the section where we start to kind of put all of our pieces together. And I know other instructors don't really heavily emphasize this section, but in my opinion, this might be the most important section in this chapter because it allows you to kind of assess any argument on your own. We will kind of talk about in the next couple of sections kind of standard arguments that we see and standard fallacies that we see and stuff like that. And so other teachers kind of lean towards the memorize all these kind of possibilities, which there is quite a few. And so I prefer to emphasize truth tables so that you can kind of develop this for anything. You don't have to fall into those kind of formulaic arguments, because although those cover a lot, the majority of what we'll see, they don't really cover anything. Okay, and so how a truth table works is we try and kind of fill in all of the possibilities for a truth table or for a statement. And so we generally talk about kind of the first column being either true or false, and then what that symbolic representation will do to that truth. So it might not make a lot of sense with negation, but let's say that my statement was true. Well, that would force my negation to become false, and vice versa. If my original statement was false, well, the negation would make that statement true. Again, those are the two possibilities. There isn't any maybes when we're talking about logic. One of the other kind of, I think we call them conjunctive logic, is the and statement. And so an and statement is true if both things are true, otherwise it's false. And so kind of this is what I was talking about, the left side of this table of the true, true, false, false, true, false, true, false. These are representing all the possibilities I could have for any statement or any two statements, right? I could either have both of them be true, one of the first one be true, the second one be false, the first one be false, the second one be true, and I could have both of my statements false. So that's the left column, and that's how the left column is almost always set up, because all that is doing is accounting for what could happen. And so once we have those left two columns built, then we kind of determine what the conjunction means with our truth table. And so I see on my column that I have two trues, so that means that P and Q have to be true. The second row I have true then false, which forces my P and Q to be false. My third row is false then true, which forces P and Q to be false. And my last row is false and false, which forces P and Q to be false. And so the truth of the matter is order doesn't really matter. So if you wanted to go major P become true, false, and then your Q be true, true, false, false. As long as all all four possibilities are covered, order doesn't really matter. That being said, if I work through examples, I kind of fall into this true, true, false, false, true, false, true, false. Kind of like flipping a coin. If you flip a coin, you have two possibilities. If it's either true or false, or true or false. There's a total of four different possibilities with two flips. But that's an aside and maybe not the best example since we didn't do so hot with probability. Okay, so for example, let's say that I have these two statements. 3 plus 2 is equal to 5, that's certainly true, and London is in England, that's certainly true. So if I make that statement, both of those statements, the only way that I could be correct, or what I was saying was true, is if both of those are true, and in this case they are. London is in England, 3 plus 2 is 5. Where if just one of my statements is false, if I claim 3 plus 2 is equal to 5, and London is in France, well, I'm lying to you, or I'm wrong, I guess, depending on the context. Because yeah, 3 plus 2 is equal to 5, but London isn't in France. And so that's kind of how this and statement works. Not kind of, this is how this and statement works. We have to have both things working in order to be telling the truth. And so if one of them's wrong or if both of them's wrong, there's a lot of possibilities for me to be lying to you or to be wrong. The only way I can be telling the truth is if both of my statements are correct. Now for the disjunction, which is kind of the or, same kind of lot, disjunction, which is the or statement, that opens up a lot more possibilities for me to be correct. And so in general, the P or Q has a, if I build the same kind of first two columns of true, true, false, false, true, false, true, false, if both of my statements are true, P or Q is true. If my first statement's true, my second statement's false, P or Q is true because I only need one thing to be correct. If my first statement is false, my second one is true, I get true. No, the only way that I could be lying or incorrect is if both of my statements are false for the or statement, the V. So example of this again, now if I'm saying, well, 3 + 2 is equal to 5, or London is in England, well, those are certainly both true, so I'm telling you the truth. But I could just as easily say 3 + 2 is equal to 5, which is true, and then it doesn't matter what I'm saying after that. I could say London is in France. I could say that the sky is, I don't know, brown. Doesn't really matter. As long as one of my statements are true, my or conjunction is going to be true. The only case where I'm going to lie or be wrong is if I say something like 3 + 2 is equal to 6, which is wrong, and London is in France, which is wrong, I guess false, so I'm going to stick with the language, in which case overall my statement is false. Statements. Now here's an example of something we haven't seen, this tilde, P, and Q. So we're going to kind of construct a table instead of falling back to those two previous cases. I mean, I guess those are the first times we've seen those cases, but those are going to be pretty standard, and probably put them on a note card would be a recommendation. I wouldn't say necessarily memorize them because they're not that hard to construct, but we're going to see those tables a lot. So it's a good idea to kind of have them down pretty pat. But this is a great example to talk about how we just, in general, if we were given kind of a logical equivalence or a logical set of statements, then we would build it by, well, starting with kind of the standard form. Again, order is not super important as long as you have a row where both things are true, a row where the first one's true and the second one's false, a row where the first one's false, the second one's true, and a row where both things are false. But this is kind of how I always start. So I start by making my truth table with these two columns, and then I need to start to construct the statement that's in front of me. My end game is to get to this tilde P and Q. Well, order of operations is I should deal with my P and Q first. So I would fill out my table, and maybe I should have kind of written this out step by step, but I would fill out my table with a P and Q. And so I would know that my first row is true, true, so that forces true. My second row is true, false, which forces false. Third row is false, true, which forces true, and false, false, which forces false. So as I was saying, if you were filling this out, or if I was filling this out on a piece of paper, I would have kind of filled out that last column square or rectangle by rectangle instead of kind of immediately being able to jump to whatever that response is. And so now I've dealt with my and statement, and so I have to do tilde. Well, what does tilde do? Tilde kind of flips any of my logical qualifiers from before. And so I had P and Q. Well, tilde P and Q, it was originally the first row was true, now it's false. The second row was false, now it's true. And the third row is false, now it's true. And the fourth row is false, now it's true. And so that is kind of my final column. And so to start to give this some context, because this so far has just been practice with truth tables, what we do at the end of the day, if we're trying to determine if an argument is true or just these conjunctions of statements, is we kind of have to track back. And so we would say, okay, I want to see if tilde P and Q is false, or I want to see if not P and Q is false or true. Well, then you have to know whether or not P and Q are true. And you would kind of go and read this table and say P is true, Q is false. That would mean that in that scenario, well, tilde P and Q is equal to true, kind of matching up that row. We'll see more of that later. Now we're getting a more involved situation here. I have tilde P and Q or tilde Q. So I'm going to start by filling out my first two columns. No surprises there. Now, order of operations, I'm going to go inside my parentheses. Oh no, I'm actually going to, yeah, I'm going to go inside my parentheses and fill out tilde p first. So tilde p takes p, flips all of the values. True become false, false becomes true. So that's my new column tilde p. And now inside that parentheses, I'm comparing tilde p to q with an or statement. Upside down v means or. So I need one of those two statements to be true. The only way that tilde p or q is going to be false is that if both of those individual things are false. So to kind of go, I'll speak through each row before revealing the answer, but to go through the first row, I have q is true and tilde p is false. So tilde p or q is going to be true. One of those things are true. Second row, both are false, so my or statement's going to be false. Third row, both are true, so my or statement's going to be true. And then the last row is my tilde p is true, and so I only need one thing to be true for an or statement. And so my tilde p or q is going to be, the whole column is going to be true, false, true, true. So now I've dealt with kind of this left side of my upside down V of my and statement. So now I need to figure out what the right side is going to be so I can compare them overall. So I need to find tilde q. Well, that's not too difficult once you understand what tilde means. I take my q column and I change all of my values, my truth values. So my first row becomes false, my second row becomes true, my third row becomes false, my second row becomes true. Again, just looking at Q, I change all of those values. True to false, or if it's false, I change it to true. And now finally, I can kind of conclude overall what my logical statement column looks like. So I'm comparing my tilde p or q with my tilde q, and it's an and statement. And so an and statement is only true if both of those values are true. Otherwise, we're going to return a value of false. So looking at my first row, true, false, that's false. Second row, false, true, that's false. Third row, true, false, that's false. And then finally, the last row is the only case where I'll have something true. So again, to kind of tie this all together of why are we doing this, what's the big picture, this means that if I had two statements, the only way that this overall tilde p or q and tilde q could be possibly true is if both of my original statements were false. That's kind of going back to the very first two columns. So let's now put all of this into practice. And this truth table is going to be pretty involved. So this is a very good slide to kind of pause and rewind or ask me questions during class, because we are constructing a truth table for, in this case, 3 statements. And so my 3 statements are: I study hard and I ace the final, or I fail the course. So I'm going to need to have P could be my I study hard, Q could be my I ace the final, and R is I fail the course. And then I need to translate that statement into logical symbols, symbolic notation. So if P is I study hard, we'll have P, and I ace the final, that's Q, or I fail the course. So or is the upside down V, and R. And so something that is nice about this diagram at the bottom is that when we see this comma, that's a dead giveaway that we are kind of closing that conjunction of logical symbols. And so that's where that parentheses comes from. And that's a good indicator that we have parentheses. And so this bottom thing that we have here is kind of what we've been working on this entire lecture up to this point, is now we're going to take this and we're going to kind of determine our end game is to kind of solve for B. Under which conditions is this argument going to be true, and under which statements are these arguments going to be false? Of course, I say argument, maybe the looser term. Just overall, this logical statement is going to be true or false. Okay. So starting a new slide, it's the exact same question now. I'm just going to run out of room because the truth table is really big. And so when I had two statements, when I only had a P or a Q, my truth table always had 4 rows that we saw. And the first 2 columns, at least how I always build them, it doesn't have to necessarily be in this way, went true, true, false, false, true, false, true, false. But now if we have 3 statements, we actually have, confusingly enough, 8 possibilities. And so when I build my truth table, I need to account for all of these 8 possibilities. And so how my brain keeps track of it is I start by saying, okay, I need 8 possibilities. So I'm going to start by going true, 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 then false, 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 false for P. So kind of splitting it in half. And then I go to my Q and I go true, true, false, false, true, true, false, false. So kind of splitting it into fourths or half of half. And then my last logical statement, I go true, false, true, false, true, false, true, false. I'll kind of just flip back and forth. And so honestly, I'm not breaking this down step by step for the truth table because, well, as far as just qualifiers go, this isn't too hard of a truth table to build. I only have an and statement and an or statement. I'm going to start with my and statement, the stuff inside of my parentheses, and I'm only going to look at P and Q. And the and statement is, well, I need both things to be true. If one thing is false, it's false. If both things are false, it's false. And so looking at my first 2 columns, the only cases that I have a true are the first row, true, true, the second row, true, true. Every other row, when we're looking at only the P and Q, has at least one of my statements being false. And so that's why the rest of my table is going to be false. Now, to do my overall result, I take my P and Q column, and now I'm going to compare it to my R column, and it's an OR statement. So OR statements work with if one of the values or both of the values are true, my overall statement or my overall symbolic form is going to be true. And so looking at the rows, I have true, true, which leads to true. Second row, my P and Q is true, so I get true. Third row, my R and R is true, so I get true. The only columns where I'm going to have false are the 4th one, false, false, the 6th one, false, false, and the 7th one, false, false. And every other case, I either have both of my statements being true, or I have one statement being true and one statement being false. And now what the second question was asking was saying, suppose that you study hard, you do not ace the final, and you fail the course. Under these conditions, is the compound statement in part A true or false? So this is very much something that I'm aware of as a teacher. I have to be careful about what I'm saying logically, because if I'm not careful about what I'm saying logically, well, that can come back to haunt me when a student says, oh, you said if I ace the final, I would pass this course. So I need to build off of this logic here. And so recall that P is you study hard, Q is that you ace the final, and R is that you fail. And so now I'm told that you study hard, so my P is true. You do not ace the final, so my Q is false, and you fail the course. My R is going to be fail. Yeah, so my R is also going to be true. So now I come to my table and find where my P is true, my Q is false, my R is true. That's my 3rd row. And so overall, it's going to be true. You studied hard, you did not ace the final, you failed the course, I was telling you the truth. So, and again, that makes sense in the context of my line of work. Quite often I say, yeah, studying hard helps you, but like that doesn't guarantee you passing the course. So that can happen. So overall, that result is true, and that's kind of what we've been building up to take these sentences where we're using and ors and if then statements and if and only if statements, and we're putting all of these results together to determine if
we get a true result, given the fact that A is true or B is false. And yeah, I guess that's it. So I think we're going to build into, I haven't quite made the slides yet, I think we're also going to build in the if-then statements, because that truth table is a little bit tricky to think of. It's very counterintuitive, which I mentioned in the last section. If-then statements are pretty counterintuitive in themselves. So this is a good introduction to truth tables. Honestly, if you feel really good about this section, you'll be able to build into the next section. But yeah, this is, in my opinion, what the purpose of this logic chapter is for us to take statements, put them in symbols, use a truth table, and then kind of read off the results to say, yes, that is everything you said checks out and you did get a true result, or actually what you said is not really true. You promised me that I would pass the class if I did X, Y, and Z. I did X, Y, and Z, and I didn't, so you lied to me. I have a really good case to kind of argue to some higher power that I should pass this course.